Good morning, dear students. My name is Ferhan Mazher, and right now we are studying the subject DMaths 4024. This is Cambridge O-Levels Mathematics, and we are working on the syllabus today. And we are working on the concept of the symmetric properties of circle, geometrical properties of circle, and that is in the D3 book, and the name of the book is D3 New Syllabus Mathematics 7th edition. This is the book which we are using for covering this topic. Today we will start working on the chapter 13, which is the last chapter of that book, and we will be doing its exercise A. This exercise 13A is about the first property of the circles, and that is that if you have a chord and you have a perpendicular bisector of the chord, the perpendicular bisector of the chord, that's the name of the property. If you want to learn about these properties, I have uploaded a full video on all the properties, the angle properties and the symmetric properties of the circles. You can watch that video. It is present in the same playlist. In this video, we are going to directly solve this exercise 13A. So let's start today's work. So the exercise 13A from the D3 book, New Syllabus Mathematics 7th edition, book 3, is showing up on your screen. The first question coming up on your screen. He says that given that, let me increase the size so you can see the whole question. Okay, so this is question number 13A, question number 1, part A. He says, given that O is the center of each of the following circles, find the values of the unknown. So if you look at this question here, we have a circle, its center is O. The radius is 13 centimeter, it is given. Here we have a chord, and this chord is basically of the length 2a, and this chord is of the length 2a. And here we have a perpendicular, this is the bisector coming from the center onto the chord. And we know that this chord has been divided into 2 equal parts, A and A. And this distance, the perpendicular distance of the chord from the center is 5. So they want us to find out the A value and the angle B, which is here. So this is radius, this is also radius. So let me show you how this is done. Okay, so here on your screen, you can see the first thing. I will try to find out the value of the A, and because this is 13, this is 5, because this is a perpendicular bisector of the chord. So this angle is 90, this angle is 90. So here I will apply the Pythagoras theorem. Hypotenuse is 13, 5 is the perpendicular, A is the base. Apply the Pythagoras. Hypotenuse square is equals to perpendicular square plus base square. So we will have A square plus 5 square equals to 13 square. So A square will be equals to 169 minus 25. A square will be 144, and A will be square root 144. So A will be equals to 12 centimeter. So this A value will be 12 centimeters. So if this is 12, this will be also 12. Now this is a right angle triangle, and here is the 90-degree angle. So this is hypotenuse. This A value is 12, this is 5, this is 13. I want to find out the value of the angle B. So if in the right angle triangle, I'm going to use this angle. So then this will be my base, and this is your hypotenuse. So I can use the cos. Cos of the angle B will be equals to base by hypotenuse. So base is 5 and the hypotenuse is 13. So when this cos, I will make this angle alone. So this cos will go here, it will become cos inverse. So in your calculator, you will write shift cos bracket start 5 divided 13 bracket close equals to, and that will give you angle 67.4 degrees. So this is how you will solve the first question. It's A part from the exercise 13A. I hope that you have understood. So the whole question is showing up on your screen. Okay, so we are going to the next part. The next question is question number 1, and it's B part. Here we have a chord, and one chord is of 26 meter. The radius is 17 meter, and the 26 chord, its distance 26-meter chord. Its distance from the center is C, and the radius 17 meter makes angle D degree with this chord, which is 16 meter. So we want to find out the C, and we want to find out this angle. Okay, so if this radius is 17, if I make a radius here, it will be also 17. And because this is the perpendicular making 90-degree angle with the chord, it is coming from the center, so it will bisect the chord. So 13, 13. So then I will apply the Pythagoras. Let me show you. Okay, so here we go. So this will bisect the chord. So this portion will be 13, this portion will be 13, because the chord is bisected. This is the radius, that's 17, and C is the question. This angle is 90 because this makes 90-degree. The perpendicular bisector of the chord makes 90-degree angle with the chord. So we will apply the Pythagoras, and the 17 is the hypotenuse, 13 is the base, C is the perpendicular. So apply the Pythagoras here. So you will have C square plus 13 square equals to 17 square. So C square is equals to 289 minus 169. So C square will be 120. Take square root on both the sides. So C will be equal to square root 120, and C is 10.95. So if you round it off, it will be C is 11 meter. So this C value is 11 meter. Now, draw a perpendicular bisector on the chord from the O onto this chord whose length is 16. So it would be 8 and 8. Now you see this is a right angle triangle. We want to find out this angle D. Here I know this radius, this is 17. This portion of the chord, half of the chord, is 8. The 90-degree angle is here. So this is hypotenuse, this is the base, this is the angle which I'm trying to find out. So use the cos D, that's base by hypotenuse, so 8 by 17. So D angle will be equals to the cos inverse of the 8 by 17. So in your calculator, you will write shift cos bracket start 8 divided 17 bracket close equals to, and that will be 61.9 degree. So this is how you will do this question number 1, and it's B part, and I hope you understand. Okay. So let's go to the next question. The next question coming up on your screen is question number 1, and it's C part. And here we have a chord which is 10 millimeter long, and its distance from the center is E millimeter. This angle is 90. Here we have an angle F. Here we have another chord which is 12 millimeter, and its perpendicular bisector is 5 millimeter from the center. And we have to find out this E value and this F value. Okay, so let me show you how this is done. And here we go. Question number 13A, D3. Question number 1 is part C. And first of all, you see here we have a chord which is 6, 6, and this is perpendicular bisector of the chord, and this will make it 6, 6. This is 5. I want to find out what is the radius. Apply the Pythagoras here. This line I have drawn myself. So R square is equal to 6 square plus 5 square. So R square will be 36 plus 25. So R square will be equals to 61. Take the square root on both the sides. So you will have under root 61. So that will be 7.8 millimeter. So once you know the radius, then make this right angle triangle. This will be 5, this will be 5, this is E. This radius will be 7.8. So we will apply Pythagoras on this triangle. So then I will be able to find out the E value. So E square plus 5 square is equal to 7.8 square. So E square will be equals to 61 minus 25. So E square will be equals to 36. And then we will take the square root on both the sides. So E will be equals to 6. So this value is 6. Then I want to find out this angle. So I know this value, that's 6. I know this value, it is 5. And then I will try to find out this angle. So cos of f is equals to 5 by 7.81. So f will be equals to cos inverse bracket 5 by 7.81 bracket close. So f will be equals to, then you will take the cos inverse, and when you will take the cos inverse, f is equals to cos inverse 5 by 7.81. So in your calculator, you will write shift cos bracket 7 divided 7, 5 divided 7.81 bracket close. So f will be equals to 50.2. So this is how you will do that question. So this is the question number 1. It's a C part. I hope you understand this question. So my dear students, exercise 13A from the D3 book, question number 2 showing up on your screen. AB is a chord of a circle center O with the radius 17 centimeter. Given that the AB is equals to 16 centimeter, find the perpendicular distance from O to the AB. So the radius of, we have to draw a circle. This is not up to the scale. We just want to diagram to understand this question. Okay, so what we will do, here you see I have drawn a circle and I suppose its radius is 17. Here is a chord whose length is 16 centimeter. Okay, so this is the perpendicular bisector of the chord coming from the center. So it makes 90-degree angle. It divides the chord into 2 equal parts. This is 8, this is 8, this is 17. So its distance from the center will be in question. So look at that question, what the question was. They say, find the perpendicular distance from the O to the AB. So that was the question. So I will apply the Pythagoras here. So it will be, this is the hypotenuse. So the perpendicular square plus the base square is equals to the hypotenuse square. So x square plus 8 square equals to 17 square. So x square will be equals to 289 minus 64. And x square will be equals to 225, and x will be equals to square root 225, and x will be equals to 15 centimeter. So the distance of this chord from the center, the perpendicular distance, is how much? 15 centimeter. This is how you will do that story sum. I hope you understand. So let's go to the next question. The next question coming up on your screen is question number 3. He says a chord of length 24 meter is at a distance of 5 meter from the center of a circle. Find the radius of the circle. Okay, so what I will do, I will. So a chord of length 24 meter is at a distance of 5 meter from the center of a circle. Find the radius of the circle. So very simple. So we will draw a circle, not to the scale. We will simply draw a circle, and suppose its center is O. We have a chord whose length is 24 centimeter. I have shown here, I have named it AB. And the perpendicular distance of this chord from the center is 5 centimeter. This angle is 90. And so this 24 will be bisected, 12 and 12. So it's a right angle triangle. Join these 2 points. This will be your radius. That is the question. And it's a right angle triangle. Apply Pythagoras theorem here. So r square will be equals to 5 square plus 12 square. Hypotenuse square is equals to perpendicular square plus base square. So r square will be equals to 25 plus 144. R square will be equals to 169. So r, take the square root on both the sides. It will be r equals to 169, square root of the 169, and r will be equals to 13 meter. So this is how you will do question number 3 of the exercise 13A from the D3. Okay, question number 4 is coming up on your screen. A chord of a circle of the radius 8.5 centimeter is 5 centimeter from the center. Find the length of the chord. So here we will have a circle, and this circle is not to the scale. We will just draw that circle. And you see here we have drawn a circle. Its radius we have supposed is 8.5 centimeter. And we have a chord here, and we don't know how much is the length of this chord. We want to find out. And this is the perpendicular bisector of that chord, that is 5 centimeter. The distance of the chord from the center, the perpendicular distance of the chord from the center is 5 centimeter. So it will bisect this chord. So there are two portions. It has divided its chord into equal parts, x and x. So this is a right angle. So apply Pythagoras here. So r square is equals to, the 5 square plus x square. So r value is 8.5. So x square plus 5 square is equals to 8.5 square. So x square will be equals to 72.25 minus 25. So x square will be equals to 47.25. So x will be equals to square root of the 47.25. So x will be equals to 6.87. So this half portion of the chord is x, and it is 6.87. So the full chord will be x plus x. So that will be 6.87 plus 6.87, and that will be 13.74 centimeters. So 13.7 centimeter is the length of this chord AB. So let's go to the next question. The question number 5 is coming up your screen. He says, given that O is the center of each of the following circles, find the values of the unknown. You see, this is the perpendicular bisector coming from the center onto this chord. So this is the distance of the chord from the center, and this is the distance of the chord from the center. And here this mark means that these two distances, they are equal. So this is the property of the circle, that if two chords have equal distance from the center of the circle, both the chords will be equal. So this A will be also 12, because equal chords subtend equal distance, perpendicular distance from the center. Or the chords which are at equal distance from the center, they are also equal in length. So because this is the perpendicular bisector coming from, this is the perpendicular distance. So this angle B will be of the 90. Let me show you the solution. This is purely conceptual thing, only concepts are involved. Here, this A, that will be equals to 12, because this is distance from the center is same as this chord has. So, and this angle B is because this is the distance of the chord from the center. And so we suppose it is 90 degrees. It's a conceptual question, no calculation is involved. Okay, so the next part is the B part. He says, here we have two chords again. Both the chords are at equal distance from the center. So if this is 22, this whole chord will be also 22. So this is the half portion of that chord. So the half portion of that chord of the, which is of 22 centimeter, half of it will be 11. So this x will be 11, and this angle, this is the distance of the chord from the center. This angle here is always 90. So let me show you the B part. It's again purely a conceptual question, and there's no calculation involved. So because this chord and this chord, they are at the equal distance from the center, so these both chords will be also equal in length. So if this is 22, this whole chord CD will be also 22. And x, this is the half portion of the chord. So 22 divided by 2, and that will be 11 centimeter. And this angle will be of 90 degree, because equal chords are at equal distance from the center of the circle. This angle will be 90 because this is the distance of the chord from the center. This makes 90 degree angle with the chord. That's why the chord has been bisected. So y value is 90. So my dear students, today we have, let me increase the size. So this is question number 5, it's B part. So my dear students, this was the question number 5, and let me reduce the size so you can see the whole thing. So this exercise 13A, we have in this video done from question number 1, 2, 3, 4, and 5. The rest of the questions I will do in my next video on this exercise. So if you find this video interesting and informative, and you have learned something from this video, please like this video. Also, if you are watching my channel without subscribing it, kindly subscribe it and share the link of this video with your friends and with your class fellows and with your junior students. In Pakistan, we study this chapter in 10 Cambridge. So thank you very much, everyone. It's a great blessing for me to be able to teach you online. Thank you very much, everyone. Have a good day and God bless you all.